everybody, we're back and we're going to work on some classwork for the definition of the derivative, section 6 of Master Math Mentor Notes. And you'll see that they've asked us to do 3 of them. For classwork examples, I am just going to take care of 1 of them. And for the frustration of dealing with negatives, I'm going to use the negative instead. Okay? So when you do f prime of 2, you're going to find that the f prime of 2 is 1 and f prime of 0 is negative 3. So I'm kind of flying off the seat of my pants right here. They just gave us the answer on negative 1 in the book, so I don't have it formally worked out, so I'll be doing this on the fly with you guys. Notice that I'm also switching over to some notebook paper here because honestly there's a lot of work that goes into this. And we don't want to drop anything, and I don't want to cram stuff together because that's not very fun, okay? So on my paper, I'm just going to title it Master Math 6, and I'm going to put classwork at the top, so whenever I find it, I know what I'm doing. And I'm going to put example 1 like this, and I'm looking for the derivative at 1 of my function, okay? So we're going to start with our formal derivative definition. So f prime of x is the limit as h approaches 0 of f of x plus h minus x over, f of x. And then I have the h. Okay? So what they did to make it a little bit easier, instead of putting in, we're doing it of negative 1. Excuse me, guys. Instead of redoing this as negative 1 plus h and redoing it 3 times for the 2 and the 0, they said just put in x plus h. Okay? There's no reason to make this harder than it is. So I'm going to say the limit as h is approaching 0, and I plug in x plus h for first. Now I'm going to write my function over here so I don't lose track of it. So I have x squared minus 3x plus 1. Remember, I do make mistakes, so if you see me make a mistake, hopefully you'll correct it yourself. It happens. I try to be pretty careful, but, you know, I'm human, so watch out. So I plug in x plus h, so I have x plus h squared minus 3 times x plus h plus 1. Now remember, you're not done. Like, we want to be done, but we still have this minus f of x. And so I'm going to do minus bracket, and that's just going to be x squared minus 3x plus 1 all over the h. Okay, notice I'm using my finger. You may even want to, if it helps you, bracket the beginning and the end so you remember what sections you're working in. I'm going to come underneath, just like this. I still have my limit as h approaches 0. X squared plus 2xh plus h squared. Remember what I said. Square, multiply and double, square. That's our perfect square. Minus 3x minus 3h plus 1. We got to drag a negative through there. Let's be careful. Minus x squared plus 3x minus 1 all over h. And that's a lot of stuff going on. So I'm going to follow it below. And it looks my x squares are going to cross out because I have a negative and a positive. Yay. I have an h squared, so I'm going to keep that guy. And I'm going to cross him out so I don't confuse myself. I have a 2xh, and that's the only one I have of that, so that's going to go there. I have a negative 3x and a positive 3x, so that's gone. I have a minus 3h, and a positive 1 and a negative 1 go away. Now remember, our goal is to cross out that h on the bottom somehow. So I have limit as h approaches 0, and I'm going to have h plus 2x minus 3 over h. So I got exactly where I wanted to be. This is going to go away, and then as h is approaching 0, this will also go away. So This now makes it super easy because really this is just going to be 2x minus 3. Okay? So now I can just say f prime of negative 1 is 2 times negative 1 minus 3, which is negative 5. I got it right. Look now, if I wanted you to come back through and say what's the derivative at 2, that's just going to be 2 times 2 minus 3, which is that positive 1 that I gave you as an answer to begin with. Okay? Notice this is a lot of work, and it was not going to fit in that tiny little box. Okay? I always like to say you have two options. We can do it right the first time, or we can get frustrated and do it multiple times. Just take the time to do it on the paper. Okay? Now let's talk about example 3. Okay, so on example 3, so again, I'm picking one that's a little bit maybe more. So I've been given this function, x squared plus x, and I'm just being told to find g prime of x. Now I'm not being told what my value is or anything. So that means that I'm going to come back up to the definition of a derivative. Okay? And so I have g prime of x equals the limit. And this time we're going to use the other definition. We're going to use the delta x, okay, because we have that change in x going on. So we're going to call out that delta x, but we can also come through and use the h2. It doesn't really matter, whichever one you like. Delta x is approaching 0. I have f of x plus delta x squared minus, see now I've already messed up my formula, minus f of x over delta x. So I know some of you want to drop writing the formula, but don't, okay? Because right now we don't remember it very well, okay? We've seen it one time. There's no way we have it memorized. So let's do it every time to really prevent us from making mistakes. So I'm going to write the limit of delta x is approaching 0. And I'm going to start my bracket and have x plus delta x squared plus x plus delta x minus, and I have x squared plus x. And see, I really probably should have gone to another line, kind of crammed my stuff in there. So let's see if we can get this to work out good. I'm going to come back over here just to make sure I have room. So I have limit of delta x is approaching 0, square the first, multiply and double, so I have x delta x, kind of creepy looking, plus delta x squared plus x plus delta x. So this was nice in that I didn't really have to worry about there was an extra negative in here, which I've had on some other problems. Run your negative through, minus x squared minus x all over delta x. So again, we're going to hope that I can get this right the first time. All right, so x squared and the negative x squared is gone. Okay. We have a delta x squared. So notice I'm putting that delta x in parentheses so I don't lose track of who's getting squared. Okay, so I'm going to get rid of him. I have plus 2x delta x. That's yucky looking. Plus delta x. And these x's cross out all over delta x. Remember, our goal is to get the guy off the bottom. Okay, we do not want to be having anything that becomes undefined. So I'm going to have the limit of delta x is approaching 0. And as I do this, I'm going to factor out a delta x. So I have delta x plus 2x plus 1 all over delta x. Those go away because they're being multiplied. This goes away because it's becoming 0. So after I cross these out, I can cross that out. So now I can say that the limit as delta x is approaching 0 is just 2x plus 1. So it's not a number this time, it's actually a little expression instead. Okay? So let's just talk real quick on our, well, I guess I'll finish off with example 5, and then I'll give you some answers for the other ones if you want some extra practice. So on number 5, I have y equals 4 over x, and I'm going to find dy dx, just like that. And again, it doesn't matter which formula you use. Sometimes the delta x is just a pain to write, honestly. So I'm just going to write dy dx. So remember, they've asked me for dy dx, so I'm using dy dx. Don't be changing it around, okay? Equals the limit as h approaches 0. And again, I'm going to take f of x plus h minus f of x over h. And I'm just going to go vertical the whole way down so I don't run out of room. So the limit of h over 0, and I have 4 over x plus h, and then I just have minus 4 over x all over h. Okay? So now at this point in time, I need to find a common denominator. Okay? So my common denominator here is going to be multiplying this top by x and x plus h. Okay? So that's what I want both of these to have. So my common denominator is going to be x and x plus h. This guy needs an x minus 4 times x plus h all over h. So I have 4x minus 4x minus 4h all over x times x plus h. And remember, when I have this on the bottom, I'm really going to multiply by its reciprocal. Okay? So I'm now going to take 4x minus 4x minus 4h over x times x plus h times 1 over h. Just like that. This guy crosses out. Okay? This guy is going away. Okay, so let me rewrite that so you see it maybe a little bit better. I'm going to multiply it. Remember, when we're doing multiplication, we're allowed to cross out as long as we're not doing anything with a plus or minus. So he goes away, and this is going to 0. So now, the limit as h approaches 0 is going to be negative 4 over x squared. Just like that. Okay? So I know that's a lot of work. It's kind of overwhelming. Just hang in there and practice. Okay? So answers, in case you needed some additional answers. So on example 2, your answer will be 4. And on example 4, it looks like we have 2 of them. We have f prime of x is 4x minus 5. And we have f prime of 3, which is 7. Okay, so if you want to do some extra practice, there you go. All right, best of luck.